Okay, so here we are on our next page of the review packet. We've got some great graphing to do. All right, the quick and easy way to graph is to look at our B. Remember, you take your last number first. It's either up or down. And then you're going to want to count your slope. The rise over the run of this graph is rise 1, 2, 3, run negative 1, 2, 3, 4. I could do a fall of 1, 2, 3 and a run of 1, 2, 3, 4. Both directions all line up. I extend my graph with arrows as endpoints. My domain is going to be all real numbers, and my range is all real numbers. Now, if you see this g of x, that's the same as y. So here I have an equation with a y-intercept of negative 8, 1, 2, 3, 4, 5, 6, 7, 8, and a slope of positive 2. So rise 2, run 1. And again, I have a domain of all real numbers and a range of all real numbers. Next up, I need to solve for y so I can find my slope and intercept. So 3y is equal to negative 5/3 minus 9. Divide, negative 5x, I'm getting ahead of myself, minus 9. Now when I divide by 3, I have y is equal to negative 5/3 x minus 3. So I can go ahead and go to my y-intercept of negative 1, 2, 3 and count my slope. Rise 1, 2, 3, 4, 5. Run 1, 2, 3. In the negative direction. 1, 2, 3. Rise 1, 2, 3, 4, 5. Run negative 1, 2, 3. Fall 1, 2, 3, 4, 5. Run 1, 2, 3. When I subtract my x from each side, that's what gives me that negative coefficient. When I divide everything by the y coefficient, that's how I end up with that fraction. All right, guess what? I've got some friendly numbers, so I'm going to go ahead and make it fast and use my intercept table. When x is equal to 0, I can cover up x, divide each side by negative 2, and I get a y value of positive 6 over 0, up 1, 2, 3, 4, 5, 6. When y is equal to 0, this 2y becomes 0, and I end up with negative 4 as my coefficient. When divide each side by negative 4, so x is equal to 3 over 1, 2, 3. So I can go ahead and graph this equation. Now, if you wanted to solve for y and get your slope and intercept, you could do that too. Negative 2y is equal to 4x minus 12. Divide by negative 2, divide by negative 2, divide by negative 2. Y is equal to negative 2x plus 6. If you look here, our intercept 1, 2, 3, 4, 5, 6. And a slope of negative 2, down 2 over 1, down 2 over 1, down 2 over 1. It checks out. All right, next one. Which graph represents this equation? I know for sure when x is equal to 0, then my y is equal to negative 5. So if I look for a y-intercept of negative 5, I can right away cross off those two. If I were to look at this equation and I subtract 3x from each side, 5y is equal to negative 3x minus 25. Divide by 5, divide by 5, divide by 5. So my equation has a negative slope, negative 3/5 x minus 25, which means it has to be this because this slope is a positive. Think about slope, dude. All right. Which equation best represents the line m. I have a y-intercept of -2. That doesn't help me. It's a negative sloped line, so that goes. And this one goes. And this is definitely a flat line, which means this slope is too steep. It has to be b. If f of x is equal to x and g of x is equal to this, complete the statements to compare the graphs. The graph of g of x is shifted up 5 from the parent graph. The graph g of x is, we're going to have it less steep than the original graph because of this 1/2. This fraction lets me know that it makes it less steep. All right, number 26. Let f of x is equal to x. That's our parent function. Y is equal to x. And the graph of g is shown. Now the graph of the slope of g of x is going to be steeper for sure, but I wonder how steep. When I look at the slope, I have a rise 2, run 1. So the slope of g of x looks like it's 2 over 1. My parent function slope is always 1. So the slope of g of x looks like it's going to be twice the slope of my parent function. My y-intercept is here, which means my y-intercept, circle the answer, fill the blank, is going to be 2 less than. It goes down 2. Let f of x equal to x. The graph of g of x shifted down 2 units. So my y-intercept is going to be there. Half as steep. So rise 1, run 2. So my slope is equal to half. Rise 1, run 2. Rise 1, run 2. Plot 2 points to create the line. And I can go ahead and create that half as steep line that's shifted down. Okay. We'll go ahead and get the last page in this video. The slope of g of x is 4 times as steep and shifted down 3 from my parent function. Remember, my parent function is y is equal to x. So if it's 4 times as steep, 4 is the coefficient, down 3 means down 3. G of x is reflected. That means my slope is going to be negative. 1/2 as steep, so my coefficient, and up 5. All right, functions represented by this rule. 2 less than twice the square of a number x is y. Plot 3 points on the grid that are represented by this rule. Each point must have integers of coordinates. All right, this one's tricky. 2 less than twice the square. So 2 less than twice the square of a number x is equal to y. When I plot 3 points, this minus 2 brings me down here, 1, 2. Now don't be afraid to get out your graphing calculator and enter these equations in, because it might be easy for you to get those values from your y function screen. So 2x to the second power, that's 2x to the second power minus 2. When I go to my table of values, here's my 0 minus 2, and 1, 0, and negative 1, 0. This is a graph that's called a parabola. It's a curve up. We're going to talk about these in the spring. If you press graph, you can see what the graph looks like. All right, on to 31. What is the domain of the function? All of my x's in a positive, all my x's in a negative direction. So it's going to be all real numbers. All right, select the correct answer. Michelle correctly solved a linear equation, and the last line of her work was 2 is equal to 2. Which statement best describes the solution that she was solving? Hey, that's one of those ones where the x's cancel out. So if the x's cancel out, that's going to give us a infinitely solution option. All right, so let's look at this one. A function f is described. What the heck is this crazy function? We have to see what the range is. So we'll go ahead and pull out our graphing calculator again, and we'll press quit. And we'll go ahead and go to the y is equal to screen and enter it in just like we see. Parentheses, x minus 5 to the second power plus 4. Check it out. It's another one of these silly graphs that goes in a curve. When I look at my table of values, I notice all of my values are all above 4. So my range of my values is greater than or equal to 4. This graph looks like this. So my range is going to be all the values that are bigger than that. All right, number 34. What is the value of this expression? All right, let's see if we can enter this in. 5, and I want the cube root. Remember, I go to math, and here's my, oh dear, try that again. 5, math, cube root of 64, minus my value of c, which is negative 2, times the square root of b, which is 9, and then plus 9. It says it's 35. Sometimes the buttons can get messy, so I'd rather fill it out myself. The cube root of 64 is 4 minus negative 2 times 9 plus 9. This is 20, and then this is going to be minus a positive, which means plus 18 plus 9. Uh-oh. Oh, I forgot to take the square root. This is a 3. Square root of 9 is 3. And then, so this is plus 6. There we go. So 20 plus 6 plus 9 is 35. All right, last problem. What is the solution to that equation? We'll go ahead and distribute. 8x minus 12 is equal to 6x plus 2. Subtract 6x from each side. 2x minus 12 is equal to 2. Add 12 to each side. 2x is equal to 14. Divide by 2. And x is equal to 7. Voila. All right, do your homework, study. Looking forward to seeing you guys tomorrow.